Another area problem. I would bet the biggest mistake here is right in this step from here to here, because people don't notice that this is e to the 1/2 x. So the antiderivative is 1 over a e to the ax plus b. So look at that. Please feel free to ask about any part of it. Wave if you need more time on this one. I can still wait. Okay, you're good. Please, yeah.
Where'd you get the 1 over 1/2? E to the 1/2.
So according to the fundamental theorem, right here, to solve this integral without a calculator, I must find this antiderivative and then compute the change in the antiderivative. This is e to the ax plus 0. So I have to use the e to the ax plus b rule, which says the antiderivative is 1 over the a multiplied by e to the ax plus b. Okay. That's not good enough. I can do more. Oh.
You can just go over why you have to change it to the 1/2 x.
You don't have to. I just think it's easier. To me, e to the x over 2 is, I just prefer multiplication. Dividing by 2 is the same as 1/2 multiplied. So that's all. Out. Anyone else? Wait if you want more time here. Okay, so we'll look at 14.
Over that property of natural laws that makes it right.
So if you don't have this on a flashcard in your flashcard deck, I would add that. It's not something that shows up all the time, but it does show up enough that you'll want to know it. So. Say again. Yeah, the multiplication is analogous, meaning it's similar enough that it's pretty easy to memorize. So the ln of A plus the ln of B. And I don't think I've ever actually seen that one needed on the AP test, but it's very similar. This one shows up handy because we're doing integrals. We always have something minus something, so this one doesn't show up at all. I don't think I've ever seen that one. Anybody else here? Please, come on.
I just have a question, when I try to do the solve, I need to know where to start. Because I just.
Yeah, hey,
That.
so everybody look up, don't miss this. Get this on your flashcard deck. Those kind of questions I love, like 3 pebbles for that. Because not knowing how to start is a very normal and common occurrence on the AP test. So the more I can give you some tips, and you can get those memorized, make sense of them, then you'll be able to get started on more and more problems. So, are you okay that when you look at it, you're thinking, hey, it's the fundamental theorem, so I've got to find the antiderivative. You're good to that one. Okay. So the next thought should be, is there a rule? Because there isn't a rule, your next thought should be use substitution or algebra. And what I do next is a little trick. I look at this and say, well, if I made u x, I'm going to have you help me out a little. What's the derivative of u? Sorry, yeah, derivative of x would be 1. I just said that backwards. But 1 isn't this other piece. In fact, the other piece is really 1 over x squared plus 1. So that's not a good approach. I try the trick the other way. If u is x squared plus 1, what's the derivative of x squared plus 1? 2x. That does match the other function, other than the difference of the multiplying factor of 2. But I can work that out later. So that gave me enough of a confidence that I should do a u substitution. So then I just start doing the steps, and then everything starts to work. That's how I get started. And I really do that on every problem that involves doing an integral without my calculator. I just think of rule first, then u sub, I do the little test. If that doesn't work, I've got kind of a list of about 5 different things I can do algebraically that usually solve the problem. And then you're on your way. Does that help? Okay. Anybody else? Wait if you want me to stay here longer. Okay. It's like an auction. You just have to make some sort of signal. Third base coach, whatever. So. One more time. Oh, please have. That's the rule. So you can't forget that. The rule is the antiderivative of 1 over u is natural log of absolute value of u. So that's just straight memorization. It's necessary because you cannot find the natural log of a negative value. So that's why the bars are there. 2 for Anna. Anybody else? Okay, next one. 13. Key here is a memorized fact. The particle is at rest when the particle's velocity is 0. And the velocity also tells you direction of travel. So positive velocity indicates travel to the right, negative left. So what I didn't do here, I should have written down that I'm trying to figure out when this is equal to 0. And they made it a trick because the 2 times when the times that will cause the velocity to be 0 are -1 and 3. So they're hoping you'll circle this. But you're supposed to notice that time is always positive. So the solution of -1 is not valid. Yeah, they trick you on that one. Tricksters, you know. Questions? Wave if you need me to stay here. Okay, next one. 16. 15's on the way. There's 15. There was an exact copy of this problem in the green packet. The numbers are different, but the idea is exactly the same. So there's the solution. I'll kind of number my thoughts. Feel free to change the acronym. The new acronym I like a little bit better, so. You want to ask about any of those steps.
Really quick, what does DREAD stand for again, just the acronym?
So D is, and really the D and the R basically kind of go together.
Yeah.
It's like you're drawing a picture, but you're also, now I didn't do it here, but I do think it's very helpful. I'm drawing a picture, I'm also drawing a Danica's chart regarding amount and rate, because related rate problems are always involving amounts and their corresponding rates. So the D and the R stand for draw the picture, draw Danica's chart, and then read the problem and write down rates. So as I read the problem, they talk about the rate at which the person is walking. The rate at which the person walks is the same thing as how fast the distance x changes. So the rate I'm writing down is dx dt, and I'm making note of the corresponding amount, which is the length x. They want to know how fast the shadow lengthens, that's dy dt, and that corresponds to the length of the shadow, which is y. So I'm building this Danica's chart with the rates that I read about. The E and the A go together. They stand for write an equation involving the amounts that you just wrote down. So that's what I did here. I used similar triangles to write down the equation that involves the amounts that I've just written down. The D stands for take the derivative of that equation with respect to time. So that's right here. That's the afternoon. Two for Adam. Yeah. Wait if you need more time here. Okay. Anybody need more time here? Okay, let's do one more.
Is there any like disadvantage to doing that every
Nope. Not a problem at all. I did it the other way because I was in the habit of always isolating, taking up the 3 first. That's not a problem. There wasn't any big problem though, I think it was last year on one of the tests, that if you remember to factor first, the problem works quite easily. If you don't factor first, it actually becomes a mess. So I would still argue that this is a safer approach, even though mathematically the other is not wrong at all. So I still think I'm going to keep teaching that, okay, let's factor first, just so we get that habit. That way if they throw in a problem like this, what I'm thinking of, you won't be fooled by it. Okay, we've got a couple of minutes. I want to give away a little more extra credit. So if you did not receive a mega pebble or 2 for being good at predicting, here's your chance to earn a mega pebble before you walk out the door. Just raise your hand, I'll call on you, and please announce to the class something important about this pink packet. Okay? Don't use your nose. Nice catch. Adam.
FRQ style.
Yeah, FRQ style, where appropriate. Doesn't mean on everyone, but for sure on the ones that are appropriate. Practice the FRQ. Bryce?
Provide the big ideas.
Yes, pay attention to big ideas. Remember, you're trying to get ready for who knows what kind of problem. You don't want to just be memorizing. Let's go here to Hannah. Yes, hey, don't lose track. First portion is no calculator. Second portion is with your calculator. Somebody else? Let's go, Julie.
Look at what you missed in this one and really.
Study the white packet first before you go working on the new one. Let's go, Alexis. Pay heavy attention to understanding. There are a good number of things that need to be memorized as well, but be really good on that. Val? Yeah, as many as you can, of course, but don't worry if you're going kind of slow and steady. That's perfectly fine. Tink?
Maybe try to do it once
If you can, but I'm understanding on this kind of thing that, you know, if it takes more than one, that's okay. It's better to do it in once, you get used to that feeling, but I don't say I would require that, Jake.
Make sure the scan count and the packet numbers are
Yeah, make sure you bubble it, right? Somebody else? Well done. Oh, sorry, Ellie, please. Yeah, don't write down more things. The more you write down, often something will come to mind. Good job, you guys. You probably would.
Peter, keep telling yourself
Give me those pebbles, bro. Keep acting in there.
That was the worst thing ever.
Some gross looks good. You know your
yesterday night.
Karen Galloway, Jeanette Lang, Hannah Brown, Megan Gurney, yes, Megan Gurney comes down, Kaden Clark, and Sam Watson. That would be great. Have a great day.
No, he's a great guy. Every time, watching anything I wrote, anytime I anything I wrote. Here's the thing.
I've done that on every single day. On only on one of them. Hey, good luck.
Thank you. Well, I need it. It's already
I need it. You'll be fine. I did.
This was predicted.
go through and fill in the need for all of those.
But I think he might be waiting to see if any of the assignments here. So he could be like, oh, this is
Right there.
My test is one of those.
Like, when you maybe should not even take it. I just don't worry about the test. Oh my god. Where have you been? I haven't seen you for like 2 months.
Where's Smith?
No way! You didn't know my name yet.
You know I would have not let them relax like that. Come on, I didn't believe in you. Yeah.
I should have.
I would have.
I broke out that. I felt guilty because the grandma was so
I'm going to tell you, maybe you should do you go skiing and this is what you get. That's probably my big secret. I didn't want to take this test. used to get my hands in a so
Yes.
so annoying. Not on no. Okay, so you change the Spanish.
Period, but I didn't talk to you.
Yeah,
So
last
I
time.
see how that web app.
Okay, I'll ask you a question, then you'll be able to do it. What's the derivative of 4x? 4. So what's the antiderivative of that? That's it. So the antiderivative of 4 is 4x because the derivative of 4x is 4. So 2 for rate. Anyone else have a question on this one? Please, Aaron.
So you know the concave up, is that because you found like the zeros of the original line of y equals
Be careful with that. Be careful with what you just said. We did not find the zeros of this function. This function actually has no zeros. What we did that confused you and made you feel like we were finding the zeros is we set these two functions equal to each other to identify, right here we're setting them equal, to identify where the intersection of the two functions occurs. So this is actually the line y equals 5. Right, it's not y equals 0. So we find these two intersections, and then what I did is I basically knew that it was either this shape or this shape, and I tested here at x equals 0, and found out that on the formula right here, x squared plus 1, when x is 0, the y coordinate is 1. On the line when x is 0, the y coordinate is 5. That's how I knew this was the correct shape. Is that your question? Two comments. Anybody else? Wait if you need more time here. And you can look this up on my website, but if you want to look and discuss, we can wait for a minute longer. So, anybody needing more time? Wait. Okay, let's look at the next one then. Seven. Another area problem. Do you have any questions about number 7 you'd like to discuss? Nathan, please.
What does it do going from 2a to 2b?
So I know that to find an integral without my calculator, I have to use the fundamental theorem, which means I have to find this antiderivative. So I went searching in my memory for the correct rule. I thought of this rule, but I realized that it won't work because this is not e to the x. So I've got e to the ax plus b available, and that rule does work because what I really have is e to the a times x plus c. Is that your question? Yeah. 2 pebbles. Awesome.
So did you make it the 1/2 just so that you can use it e to the ax plus b?
Yeah, I don't like dividing. I will do this on pretty much every problem. Change it to multiplication, just easier for me. So 2 for Dawson. Anyone else? Wade, if you need more time on this one, Wade. Oh, please.
So if we want to get like perfect notation, stuff like that, what would you recommend like a thought process organization?
Oh, gotcha. Really, as far as making sure you don't lose points on an FRQ, the only things that are essential are make sure when you write an integral, you include dx. That happens often, people forget that. Make sure if there are parentheses required, you have parentheses. An example of that would be something like this. If I write the integral from 2 to 5 of the function f, subtract g, and then I put dx, I have to have a parenthesis here and here because it's all of this times dx. So that's common. Back here, really, I just find the antiderivative, write it down. And once I found the antiderivative, don't put an integral sign anymore. It's now, we found the antiderivative, we need to find the change in the antiderivative. So, really, as long as equal really means equal, you're fine.
Alright, but you said for advantage to like basically rewrite the question in like kind of translate it to math basically, like given told you I don't know where the example.
Kind of depends on the question.
Kind of like number 10 on this where we draw the picture on the new packet, where it says find like the equation of the line can
Oh, I know. Yeah. I do all that just to make sure I don't get mixed up. They don't look at everything. You can draw pictures, you can have little notes and things. It's just that when you start writing equal, make sure equal really is equal. Don't lie to them.
Right, so should we like separate our pictures and our lines?
No, it can be somewhat free form. It's okay. Allison, 2 for Aaron.
Oh, well, that's good.
No, he asked me a different question, sorry. Go ahead.
How did you get from 2A to 2B?
So right here.
Somebody did that? Oh, that's mine.
No worries. Anybody else? Please.
This is motivation on 2B is like when do we have to sort of parentheses there as so the next step you have it over in full.
Right here?
Yeah, from there to you have 2 going into both one grade whatever. I know it's the same either way.
It doesn't really matter. If you go from here and you say in your mind 1 divided by 1/2 is 2, and you put a 2 here, that's fine. Then all you're doing is saying, hey, I've got to take this antiderivative and find the change in the antiderivative from 2 to 0. But because 2 is a multiplying factor, I just left it out. You don't have to. This could have been 2e to that minus 2e to that. It doesn't matter. Either way. You do have to make sure that, if necessary, you have parentheses here and here to indicate that all of this applies to the bar. That's important. Anyone else? Next one. 14. Feel free to ask about anything on 14. Please, Bobby. Which number are you looking at?
Or like, get the U for number 1.
So, I know when talking just a second. I want to show a trick I use. If you've seen it before, great. If not, watch. When I see an integral that needs computing and I don't have a calculator, I think, okay, fundamental theorem, so I need antiderivative. My next thought is rule, but no rule fits. Next thought really is, let's try the U substitution trick. Here's my trick. Let's see. If I choose U to be x, Dawson will help me. What's the derivative of x? So the derivative of x is 1. But 1 is not this thing here. In fact, this thing here is really 1 over x squared plus 1, so that's not a good choice. So instead I think, let's make U x squared plus 1. So, Elika, what's the derivative of x squared plus 1? 2x. Okay, that's good, because that's an exact match for x.
Is Stephen Lenhoff in class?
Yes.
He's being checked out. Thanks.
So that's a good match. So I can say that's going to make my u substitution work. I pick u equal x squared plus 1, and I just do the steps. Making sure that when I write equal, it really is equal. Other questions? 2 pebbles for Abel, 2 for Elka.
How does it, whenever you do the u substitution, do you always change the x,
The limits of integration to prepare us. Anyone else? Wade, if you need more time on this one. Okay, next one. 15. Please.
I got stuck because I used the ratio from the length of the triangle
Just tell me what ratio you wrote.
the x plus y over 3 equals x over 6 x
Hold on 1 second. So x plus y over 15 equal. That's fine.
I just got stuck further down once I was trying to calculus stuff started. I got some of those 4 plus y over dx equals 5 halves.
Let me intervene a little bit here. Okay, what I would memorize is that most of the time, if you have an equation, everybody look at me, there we go. This is a really good flashcard fact. I don't know how to put it on a flashcard, but listen to my words first and ask questions of me too. Really what's causing you to get stuck is this. Most of the time, if you have an equation that has x and y kind of spread about, it's best not to do anything. Just take the derivative of both sides and proceed. However, this is an exception because the algebra to rearrange is so simple, it really is of value to do some rearranging. In fact, I would have done one more step here. I would have said, let's divide both sides by 3. So we end up with 3y is equal to 2x. And then it just makes the rest of the calculus a lot easier. I'm not sure what went wrong on yours, but I want to avoid the quotient rule whenever possible. That's something I watch out for. So I certainly want to get rid of the denominators. So with one fraction equal another, it's easy to multiply and get rid of that quickly like I did here. But anyway, that would be my advice. I'm not sure what went wrong, but I'm not sure I helped you either. two pebbles. You look at your work. Oh, I got you. Yeah. This is actually fine. Everything's great. It's just that fraction is kind of funny. Yeah. I get you. So it's just that you'll have to do a fraction now, but you can handle that. It's not that bad. I got you. 1 second. So at this point, really, you just have 4 plus x equals 5 halves x. So I would just move this to that side. So you have 5 halves minus. So you have 5 halves dx minus 2 over 2 dx. 4 would equal. Right there, you'll see it. Because it's 1. But 1 is the same thing as 2 over 2. So you have 5 halves of something, subtract 2 halves of something, which is 2 halves of that something. Does that make sense? And now you can just go by 2 divided by 3. Any question? Please.
Scroll down.
Yes, it doesn't go too much slower.
Where is the A?
This is actually 9, it's just written badly.
Oh.
Sorry.
Okay.
Yeah, it does look like an 8. It came from here. So sorry about that. Please, sit down. No one talks so I can hear.
It sounds like a dumb question, but I just don't know how you made x plus y over 15 equal x over 6 is 15 over 6 equals x plus y over 5. I
Gotcha.
just don't know how you do it.
This one here, right?
Yeah.
I'm going to have you help me, and I think you'll see it. Paris, you can here.
Yeah.
Okay, so scroll back up. So part of the reason I know how to do this problem is because I've done it before. Like, I think this is a pretty difficult problem if you haven't had some experience with it, but they've given this one on the test several times over the years. So I draw the triangles like that. So are you okay that they are similar triangles? Okay, once you know that they are similar triangles, creating the equation is, you can kind of do it any way you want. Like, just tell me one side of one triangle, I don't care. Okay, then I just write that down. Now, this could be the bottom of a ratio. It could be on the other side of the equal sign. It doesn't really matter. So now you just tell me some other side, anyone you want. 6. Okay, you want to put the 6 here? Would you like to put the 6 here? Would you like to put the 6 here? It doesn't really matter.
I'll show it underneath.
So like this?
Yeah.
Okay, now you've done that, you have to make sure that everything else corresponds appropriately. So you have to say, okay, 15 is the vertical side of the large triangle. 6 is the vertical side of the small. So you're taking vertical of the large compared to vertical of the small. So you've got to do something similar here. That's why it's called similar triangle. So pick another side.
The shadows
So you have the big triangle or the small.
are the small.
So you got to give that a name, so we'll just call that X. Is that what I did? I called it Y, so let's be consistent here. So I called that dimension Y. Okay, now the Y has to go here or here, but you have to put it in the right place. It's got to correspond. This was the vertical side of the large, vertical side of the small. So does Y belong in the top or the bottom? Bottom. Now you've got to find the right spot here, so what would you say?
It would be x plus y.
Does that make sense?
Yeah.
Does that feel better?
Yeah, I thought that you would just rearrange the one on the board that you had written, and that's why it was the other one that you wrote on the whiteboard.
Oh, over here, gotcha.
Yeah, I just thought you could kind of rearrange that, and it was an easy session.
What I was trying to show here is that I started with this equation, but you don't have to.
Okay.
This is just as good. Does that answer your question? Two pebbles. Anybody else need more time here? Okay. 16. Wait, if you need more time here, I'll wait. Otherwise, we'll go to the next one. Cool. $26. We say wait.
Sorry, wait,
Oh.
this is 16?
This is 16.
Oh, okay.
Yeah.
I'm sorry, sorry.
Take 5.5 seconds. Then there would be, well, actually, they can do that. -1 doesn't make sense. But if you were just asking to find out 0, you could say that. And these were the choices. Oh, this is the right choice. This is the alone is not the only one. You're missing one is
I've never taken a
I am a retard. So let's 1/3 times 1/3 is not 1/3.
yeah, we need to find the 0 on this one.
I'm going to get like a 2 or a 1. 0. I'm going to go 0. Because 1/3 times 1/3 is 1/3.
They write 1
I think I missed 3 problems because
they won't never have 2 extra. So there's a reason why they have to make
That one's right.
like my question
I'm like,
you're wrong.
Okay, that's where I was confused. I get it. You just did good, really. I don't know. If I knew how to do a graph, I
so, Hey, just a warning to everybody. Hey, everybody look at this one for a second. I want you, like I got eyes on the board. There's actually something important here. Like even if you got it right, you really want to memorize what I'm about to tell you. There was a question on, so they're putting out a lot of tests now for practice tests. So on the practice test last year, or may have been the real test even, they did something that would fool a lot of students. But if you'll remember what I'm about to tell you, it won't fool you. Okay, you've noticed that throughout the year, I pretty much always factor whenever I can. It just always makes the problem easier. The same is true here. If I factor out the 3 first, which is what I thought to do, if I factor out the 3, then when I'm solving the problem, I get to here, and I'm going to replace the x dx, the x squared dx, with 1/3 dx, okay? Then the 3 will multiply to make 1, everything's fine. There was a problem on the test last year. If you didn't think to factor first, you actually, the problem gets kind of messy. It's hard to find the correct answer. If you remember to factor first, it's pretty simple. So just, I would always factor if you can. So answering Aaron's question, this doesn't really go from this line to this line. This is my work kind of figuring out my values to substitute. Now I'm going to actually start making the substitutions. So this is just a restatement of the original integral. Then I say this integral is equal to, I've got to have equal here, to this integral because I can make all my replacements. This is replaced with u, x squared dx is replaced with 1/3 dx, and I still have the multiplying 3. So really I'm going, once I have this information, this is the original problem, I've now made the substitution. Thank you, that's a typo. It's a righto, whatever that means. Yeah, that should be. Thank you. Okay. Moving out. Okay. We're kind of out of time, so I'm going to do one more thing before we wait for the bell. It's going to ring any minute now. 3 minutes. I'm going to give away